welcome you all in this NPTEL online certification course on mechatronics. Today we are going to talk about the microcontrollers. Here in this schematic of the different mechatronic system components, you can find microcontroller over here in the digital control architecture. Microcontrollers, as I explained to you in my previous lecture, is an integration of microprocessor with memory and input output interfaces, okay, and other peripheral such as timers on a single chip. The microprocessor have limited amount of ROM and RAM and are widely used for the embedded control systems. A microprocessor system with separate memory and input output chip is more suited to processing information in a computer system. So, here you can see how this looks like. Actually, we have the CPU, we have the ROM, we have the RAM, we have EEPROM and EEPROM. Okay. So, this is there, EEPROM and EEPROM is there. You have input and output data register here. So, input output ports are there, and input output control and status registers are here, and you have the data bus over here. So, if we look at further little more detail on the microcontroller here. So, we can see that we have CPU, RAM which is a volatile data, and ROM, EEPROM and EEPROM as I defined these memories devices in my last lecture. These are non-volatile software and data. We have digital input output ports, and of course, that is there, and then the serial communication units are here, timer is there, and analog to digital as well as the digital to analog converter are over here. Okay. So, digital to analog converter, as you can see that these are the devices which actually use the analog signals, that is the analog actuators, amplifier and analog display. Okay. And analog to digital converter is needed from, if the input is there, say from analog sensors, potentiometers or the monitored voltages. Okay. And the serial communication here is for external EEPROM or other microcontroller or host computer, and the digital input output ports are used for switches, on off sensors, external analog to digital or digital to analog converter, digital display as well as on off actuators. Okay. Here the various terms used over here, say SPI, that is serial peripheral interface. These are all for the serial communication basically. I2C, that is inter integrated circuit, UART, that is universal asynchronous receiver transmitter, and USART, universal synchronous asynchronous receiver transmitter. 8-bit microcontrollers, here are some examples, a Motorola 16SC11, Intel 8051 and a PIC 16C6X oblique 7X. 16-bit microcontroller are Motorola 68SC16, 32-bit microcontroller is Motorola 68300. Okay. So, these are the example of microcontroller. So, if we look at M16H 68HC11 Motorola microcontroller. So, this is the architecture basically. So, you have the CPU, you have the all memory devices over here, okay, and you have say timer system over here, okay, and you have the serial peripheral interface, serial communication interface, okay, all these, and here address and data is there, Okay. So, this is the architecture for Motorola M68 HC11. Similarly, we can see the architecture for the Intel 8051 microcontroller. Okay. So, again we have the CPU, we have the RAM, we have the ROM, interrupt control is there, register is there, oscillator is there, bus control, input output ports are here, okay, as well as the serial ports are there, okay, and here you have the timer. One of the very popular microchip microcontroller is the PIC, basically which is peripheral interface controller, and this is based on the Harvard architecture. And again here we can see the various components of it. Okay. So, we have say CPU is there, then you have the memory devices over here, then other program code protector, watchdog timer, power up timer, oscillator startup timer and all. Okay. Then what we have interrupt logic over there. Here all interfaces are there, which I discussed during the last few slides. Okay. A to D converter and all are there. So, for previous microcontrollers, separate buses are not used, and thus program data fetches have to wait for read, write and input output operations to be completed before the next instruction can be received from the memory. And with Harvard architecture, instructions can be fetched every cycle without waiting, each instruction being executed during the cycle following its fetch. Okay. Harvard architecture enable faster execution speed to be achieved for a given clock frequency. Atmel AVR microcontroller and Arduino. Okay, let us look at these the features of these. So, Atmel AVR microcontroller uses modified Harvard architecture with the program and data is stored in separate memory locations. Arduino is a small microcontroller board with complementary components which has been designed to facilitate the use of the microcontroller in the control projects. Arduino board is open source. So, this is the block diagram for PIC16F84 microcontroller. Okay. So, again here we could identify the different components of it over here. So, you have say RAM is there, then instruction register is there, okay, power up timer, oscillator startup timer, all timers are there here, okay. Then instruction decode and control timing generation is there. Okay. So, here you have the EEPROM data memory is there, okay. Flash program memory is over here. Okay. So, you have the ALU over here. So, this is how this indicates the block diagram for PIC16F84 microcontroller. This PIC16F84 is a 8-bit CMOS microcontroller, and it has 1792 bits of flash EEPROM program memory, and this flash memory is non-volatile computer memory that can be electrically erased and reprogrammed. Okay. It has 68 bytes of RAM data memory and 64 bytes of non-volatile EEPROM data memory. Here we can see the pin out connections of PIC 16F84 with the required external components. It is a you can see that it is a dual inline package. So, we have basically the two lines over here and there are total 18 number of pins. So, you can see 1 to 9 at one side and 10 to 18 at the other side. So, it is a dual inline package IC, and bidirectional lines can be individually configured in software as input or output pins. Okay. So, that we can do. Now, here if you look at there is a 5 bit of bidirectional input output pin which we call it as port A. Okay. So, this is port A actually RA0, 1 and 2, 3 and 4. So, these form actually what we call it as port A. Okay. And 8 bit bidirectional input output pins are port B basically. So, here you can see that here is 8 bit 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, this is 8 bit bidirectional input output pins of port V. VSS and VDD, as you can see here, VDD and VCC basically these are power supply ground reference actually. Okay. So, SS basically represents source and positive supply. So, this is VSS and VDD, and you have actually OSC1 and OSC2, that is basically the crystal oscillator crystal inputs over here, and there is a master clear port basically which is active low. Okay. So, this is the pin out connection for PIC 16F84. Important feature of PIC is to process interrupts basically, and interrupts occur when a specially designed input changes states, and when this happens the normal program execution is suspended while a special interrupt handling portion of the program is executed, and the power and grounds are connected through VDD and VSS ports. As I said, the master clear pin MCLR is active low and provides a reset feature here, and PIC clock frequency can be controlled using different methods. Okay. The clock frequency is set by connecting a 4 megahertz crystal across the OSC1 and OSC2 pins with the 22 picofarad capacitor grounded. Now, let us look at the programming a PIC. To use a microcontroller in mechatronic system design, software must be written, tested and stored in ROM of the microprocessor. Software is written in PC and downloaded to the ROM as machine code, and program is written in assembly language. A cross assembler generates the machine code. The assembly language used to program PIC 16F84 consists of 35 commands that control all function of PIC. These set of commands are called instruction set for the microcontroller. Now, let us look at PIC Basic Pro. PIC program can be written in the form of BASIC, okay, and this is called PIC Basic Pro. Okay. PIC Basic Pro compiler can compile these programs, produce their assembly language equivalents, and this assembly language can be converted into the hexadecimal machine code or hex code that can be downloaded directly to the PIC Flash EEPROM. Okay. And once loaded, the program begins to execute when the power is applied to a PIC. So, here are the basic math operator or functions with their description. Say A plus B is for adding A and B, this is for subtraction, of B from A, this is for multiplication, division. This actually means shift A n bits to the left, and this actually means shift A n bits to the right, and here return the cosine of A max B returns the maximum of A and B. Then A min B returns the minimum of A and B, then sin A returns the sine of A, square SQR A is basically returns the square root of A, and A and B returns the bitwise AND of A and B, and A vertical bar B represents returns the bitwise OR of A and B, and this one returns the bitwise exclusive OR of A and B, and tilde A returns the bitwise NOT of A. There are some pick basic pro logic comparison operator basically. So, 1 equal to or double equal to sign basically represents equal, and this is the representation for not equal, this is for less than, this is for greater than, okay, and this is less than or equal to, and this is for greater than or equal to. Okay. And then we can similarly have various statement and their description. For example, you can refer to some of the standard textbook, and the textbook which I will be giving at the end of this lecture in the references to look at some of the descriptions of these statements basically. Okay, so, add assembly statement, insert one line of assembly language code, add SIN channel where read on chip analog to digital converter like this. Okay, so, likewise there are various functions which whose description you can read. Okay, call assembly level, call and assembly language subroutine, clear 0 all variables, clear WDT, that is the clear the watchdog timer, count pin period where number of pulses occurring on a pin during a period. Okay, then data define initial content of on chip EEPROM, all these things are there. Then similarly, I am just highlighting some of the important ones. So, enable means enable on interrupt and on debug processing, enable debug, enable on debug processing, and end means stop execution and enter low power mode. Okay. And then we have the for say for loop basically. So, count start to end step, and then you can have the body statement. Similarly, repeatedly execute statements as count goes from start to end in a fixed increment. Okay, produce up to 2 frequencies on a pin. Then you have the go to label, continue execution at the specified label, high pin, that is make pin output high. Okay. Then we can have the conditionally jump to a label. So, if log comp, then label something like this. Okay. And conditional execution of statement, that is if and else type of statement. Okay. And it terminates with the end if statement, and input pin making a pin an input, low pin make pin output low, output pin making pin and output, and so on. So, likewise we can have, there are many more commands which I have not discussed over here. As I said, you can refer some standard textbook or PIC 16F84 catalog to know more number of programs. Then now let us see that how do we design a microcontroller based system. I am taking a small example over here, and in the last week of this course, I have taken around 5 examples based on for the mechatronic system design examples. There you can find out the further details about this. Okay. So, to method for the design of a microcontroller based system basically starts with this. First of all, you have to define the problem and then draw the functional diagram. Okay. After the functional diagram, you have to find out what are your input output requirements. Okay. And once input output requirements are there, select an appropriate microcontroller model, select, identify necessary interface circuit, decide on a programming language, draw the schematic, draw a program flow chart, write the code and then build and test the system. So, these 10 steps actually can summarize the design of a microcontroller based system. Now, factor considered while selecting a microcontroller. Okay. So, these factors basically depend on how many, that is selection of a microcontroller depends on how many number of input output pins you need basically, what are your interface requirement, what is your memory requirement, okay, how many number of interrupts are needed, okay, and what processing speed is needed. So, based on these you can select an appropriate microcontroller for a particular application. Now, let us take an example of say the DC motor position and speed controller. Okay. So, in most of our mechatronic system design, we often use the DC motors. Okay. So, whether it is a if you want to make a simple mobile robot, okay, or you want to make a simple manipulator. Okay. So, often the DC motors are used. So, I have taken the DC motor position and speed controller example. Now, this solution utilizes say 2 PIC microcontroller. The main PIC is called the master PIC and control most of the system functions, and the secondary PIC is called the slave PIC because it provides the information to the master PIC upon the command. There are 2 software listing, one is for the master PIC that monitor the keypad, provides a menu driven user interface on the LCD and drives the motors. So, here basically you can see that you have a master PIC, you have a slave PIC, we can have a LCD display over here. Okay. So, these are the basically the microcontroller, and I have a DC motor here whose position and speed I want to control. Okay. So, the input for this is through H bridge basically, that H bridge I have talked a lot when I was discussing the actuators, and the output of the motor or the speed of the motor can be taken from over here. So, quadrature decoder and counter through this can be there, and then it could be fed to the slave PIC. Okay. And for providing the input we have the keyboard, and the keyboard decoder could be there to decode the book, decode the commands of the keyboard. Okay. And you can have a buzzer input. Okay. So, this is there. So, the other listing of the slave PIC that monitors the digital encoder sensor on the motor shaft and transmit the position information to the master PIC as I said. So, this picture which I have taken from his handbook. Okay. So, you can see the connections for this. Okay. So, this is your master PIC, and you have the slave PIC over here, you have the display unit over here, here is the keypad. okay, here is the motor. Okay. Other peripheral connections can be made, and for its programming you please refer Histand and LCR Tor reference, okay, for the programming part of it. Next application of microcontroller we can see in a washing machine which uses say microcontroller used is Motorola M68H C05 B6. Okay. That is there. So, again here basically we have the temperature sensor and speed sensor, they are connected to analog to digital converter. You have the timer, pulse width modulation is there basically to control the motor speed. You have the CPU, you have the memory ROM and EEPROM here, and there are the port A, port B and port C basically. So, port B is for the display, port C is for the input, that is keyboard, and in port A we can have connections for heat control, motion direction, buzzer, door lock, water control pump, cold water valve, hot water valve, as well as the water level indicator. Okay. All these things could be there, and the CPU have this door switch. When door open, the program is interrupted. Okay. So, all these things this block diagram basically explains the use of the microcontroller in the washing machine. A PIC project, there could be a systematic debugging procedure actually for the PIC project, so that the mistakes are minimized. So, what we do is that before writing and testing the entire code of your project, always start a very simple program. So, this is always advisable. Okay. Once the PIC is known to be running properly, then incrementally add and test portions of your code, one functional component at a time. Okay. Use LEDs to indicate status and location within your program when it is running, and to indicate input and output states. Be aware of the different characteristics of the input output pins on the PIC. If you are using a PIC with no internal oscillators, okay, make sure your circuit includes the proper clock crystal and capacitor component. Make sure you carefully select all the configuration bit setting when downloading the code to a PIC. So, the oscillator, timer and selected pins functions are defined properly. So, these are the references which you can see for the further reading, such as Mechatronics by Bolton and Mechatronics by LCR Tor and Histand. Okay. Thank you.